So good afternoon everyone. Today we are going to discuss about the reduction procedure. So we know what is a reduction procedure. So reducing the given control flow graph. As we know, the control flow graph, which consists of some nodes with some links, and the path reduction procedure is nothing but reducing the given control flow graph to only two nodes, initial node and the destination. And the path expression which you are going to get by reducing the remaining nodes will contains the both achievable and unachievable paths. So node by node reduction procedure is a procedure to reduce the given control flow graph. For that we need to follow some steps. The steps are, first of all, we need to implement three methods in this particular procedure. One is path sum, path product, and means whenever in the process of reducing the nodes, if there exists any serial links, then we will apply the path product. And second is whenever we see the parallel links between the two nodes are which will occur in the process of reduction. If any parallel links occur between two nodes, then we will apply the path sum. And third one, if there is any loops are there, we need to reduce the loop by using the loop rule. This process will continue till all the nodes will be removed, so except the initial and the destination nodes. So we know what is path sum, path product. We'll see how we'll apply the loop. So because as we know the path sum and path product. So for suppose see here there occurs there are two nodes. So and this is the loop. It's a self loop. To remove this node, so for suppose to remove this loop, before removing this, so we need to remove this self loop. So for that, so this self loop will be removed by placing the asterisk on that particular link variable B. See here, so B asterisk, it indicates that B is a self loop. So this particular node passes through C and also through D. That's why here by removing the self loop we are indicating or we are mentioning this particular B asterisk through C as well as through D. We'll see one more example. Yeah, see here. So see here. So node 2, there is a self loop which consists of B, D. To remove this self loop, so we need to multiply this BD by placing the asterisk to BC. So only because this passes only through this one, through this link. So there is no more link from 2. Right? So the out link is only 2 to 4. So that's why we are making this BD asterisk and we are making it as a product to BC. BD asterisk BC. See here. We'll go to reduction procedure example. See, let us consider this example. This is a control flow graph and we have total 10 nodes and we have to get the path expression between only two nodes, means initial node and the destination node, starting node and ending node. So for that we need to remove these particular remaining nodes one by one. First of all, we have to select one node which we want to remove. Before remove that node, we have to check whether there is any serial links or parallel links will be there or loops are there. So according to the procedure, so we need to apply the method. So see here, I am selecting the node 10. I am selecting the node 10. So node 10, so there is a link from 6 to 10 as well as 10 to 9 and 10 to 7. This is a serial from 6 to 10, 10 to 9. 6 to 10, 10 to 7. So we have to apply the serial rule. So see here, 6 to 9 IL, 6 to 7 IM. We have applied the serial rule and node 10 is removed. Next is see, again I am selecting the 9, node 9. So node 9, so here node 9 from 6 to 9, 9 to 5, 6 to 9, 9 to 5. And if I remove this node, here see here, 8 to 9, 9 to 5. It's a serial link. And also this will become, no, so right now only the serial link will be allowed here. So that will get, see, 6 to 9 ILH, 8 to 5 KH. ILH, KH, and node 9 is removed. Next is I am selecting another node to remove, that is 7. So 6 to 7, 7 to 3, 4 to 8, 8 to 7, 7 to 3. Apply the serial rule. So and we will get this one, IMF and GJF. Or else, so here this one is there, so we will apply only JF. If I remove this 8 node, see, 4 to 3, 4 to 8, 8 to 3, 4 to 8, 8 to KH. So this will apply the serial rule and this will become also serial rule, and it will happen the parallel rule here. So C plus KH, see here, 4 to 8, 8 to 5. So this will becomes like this. So here it will form the parallel link. So we are applying the parallel rule, C plus K, C plus GKH, and here GIF. And next one is, sorry, now I am removing this node. So this is the path control flow graph I am getting. So next one is I am selecting, here I am selecting the node 3. Wait a minute. So before selecting another node, I am checking whether there is any loops will occur. So see here, 4 to 3, 3 to 4, 4 to 3, 3 to 4. So this will become a self loop at node 3. So for that, so make it as a loop, and here also make it as a loop, and I am getting BJIF, and this B will flows to between 4 to 5 also, nothing but B to 4, 4 to 5 alage. So B to 3 to 4, 4 to 3. So this will become the self loop, and this will flows, this particular B will flows to through 4 also. So that's why BGIF and B of C plus GKH. So next one is I need to remove this self loop. So I will check whether there is any other methods, so any other things to apply. See here, this is also a self loop, 6 to 5 to 6, 6 to 5, 5 to 6, 6 to 5. So I am applying the I'm applying the loop rule. So D of ILH as well as D to E. So here in this particular example, this D has taken, this particular D has taken to previous one, so previous nodes. So that's why here, see here, so this is D. We can take like this also, or we can apply to DE also, nothing but 6 to 2 here. So the BJIF, so the BJIF is a loop. Before removing the self loop, so BJIF of asterisk of B of C plus KGH, and I am removing this particular self loop. So again this forms the self loop here. So I am removing this particular thing, and I am getting so ILHD asterisk E, and once again here 3 to 6, 6 to 3, 3 to 6, 6 to 2. So again this particular thing will form a self loop here. So self loop of 6. So entire this thing. So ILHD asterisk IMF of BJIF asterisk of B of C plus GKH into D, and this particular thing will flow through this also. So I have to apply the particular this thing is to previous node product. So that's why here I'm producting nothing but applying the path product to A into of as well as this particular thing. So if I remove this particular self loop, what will become? Entire thing will become into asterisk. I have to see entire thing of asterisk, and finally I'm getting only 3 nodes, 1 to 6, 6 to 2. So if I remove this 6 node, so entire path expression I will get is this thing. This is about the node reduction procedure. I will take, possible time permits, I will take one more example. This example, here I have taken one control flow graph which consists of 5 nodes. So 1 to 3, 3 to 4, 4 to 5, 5 to 2. So I have to reduce this particular control flow graph between 1 to 2. See, for that, so I have to check before removing any node, I have to check whether there is any parallel, serial or loops are there. See here there is a loop. Before going to remove this particular node 5, so I have to remove this self loop. So for that, so I have to apply the loop rule. So 4 to 5, 5 to 2, E asterisk F. So D, and here there is a parallel loop. So 3 to 4, B plus C, and 1 to A. Now entire thing is parallel, serial. So I will get A, sorry for this thing, A into B plus C, D, E asterisk F. This will be the path expression for this particular control flow graph. Simple, we need to follow 3 steps: product, sum and loop. If loop is there, we have to apply, we have to mention that in asterisk, whatever thing. Before removing any self loop, we have to mention that by representing the asterisk symbol. Okay. So this is all about the reduction procedure. We will see the next topic in next class. Thank you.